Hey guys, this is Leonard Koch. A couple of days ago there was a discussion on the Softimarsh mailing list about this shot here and sort of shots like it. So let me switch over to this here. Basically a solid shape breaking up into strands like we see here and forming back together eventually. And there were a couple of suggestions, but nobody really came up with a solution. So when I saw that, I thought, hey, this is actually pretty easy to do with LKLightning 2.0. And so yeah, I'm going to show you how to do that today. LKLightning 2.0 isn't out yet, but it will be out in a couple of days. So well, let's take a look. So here we are in Softimarsh, and this is basically already a finished scene. This is the product. This is what we'll do. So we have this null here flying around and triggering this motion, this breaking up of the particles, of the strands. So pretty cool. And yeah, let's build it. And as you can see, this shades completely straight and it breaks up, just like we have in our clip here. Alright, so yeah, let's just make a new scene. And yeah, let's get started. Now, as we can see here, this is sort of arranged, the particles are arranged in a grid-like pattern. LKLightning doesn't really do that, so we'll just have to build that real quick, but that's insanely easy, so that will only take like a minute. Okay, so let's go to primitive, and point cloud empty. Fantastic. Let's open up our ice tree by hitting Alt-9, and let's create a non-simulated ice tree. And now we'll simply create our grid and sort of cut it out with a mesh. So let's start out by going to 3D grid. What's it called? Grid. Generate 3D point grid, and this just comes with Softimarsh, and it's a useful little compound. So we only basically need a flat grid of particles, so we don't need more than one in the Y direction. Y dimension doesn't matter. Let's go with like 50 particles, and I'm just going to link these here so that we can, have a uniform grid. And the same with the size of the grid. And let's just make this 100 so that we have some space to work with. Okay, so that looks pretty cool. But right now, if we were to emit from this wouldn't really work. So what we'll do is we'll have to cut our shape out of this. So we're just going to go with a 7.2. Let's go to text, solid mesh, and pull this up so you can see. Let's make this 7, apply, take a look at the Explorer, freeze this, let's call this 7 underscore mesh. We don't need that anymore. Move. I'm just moving this around here right now. And I'm sorry, this is sort of an advanced tutorial and assumes that you already have knowledge of Softimarsh. So I'm not going to explain every little step here. And let's center that. And now let's scale it up so it can match this. Let's go to a top view. Wonderful. And let's just scale this up until it sort of barely fits. Yeah, like that. Maybe we can move it around just a bit so it matches up a bit better with the particles up there. And this looks cool. Okay, so I would call that done. Now, of course, this hasn't done anything. We just have a mesh here right now. But let's freeze the transforms for it. Okay, and now let's go back to our ice tree by hitting Alt F9. And yeah, we basically need to cut out the particles that are not inside our 7, since we want to emit from the ones that are in there. So we can just go delete point and search for point and volume. Let's get our actual mesh in here so we can check if our points are in its volume. We can just plug this in here into our deleted port, and bam! Every particle is gone because we don't have our actual point position. So we need to pull our point position in here to check real quick, hey, is basically what we're saying here, is this point position in this mesh? And if so, give us a positive boolean. Now it is deleting the points that are inside of the mesh, which is not what we want, so we can just go in here and click negate, and bam, there we go, we have our particles. So we have our grid set up, and let me just quickly save this here so that we can go back to this in case anything crashes. Wonderful. And so yeah, all we have to do now is hit primitive LKL strands from selections. You will see that LKL adds these three options here. We want to emit strands, so we take this here with our point cloud selected. And it's just going to shoot through that, and bam, there we go. This doesn't look too good, but we can definitely work on that. So with our new created point cloud, LKLightning strands from selection selected, we're going to hit Alt 9 and, you know, mess around with this. So what do we have here? As you can see, we have quite a few compounds here. We have our core, in which every compound from LKLightning plugs in. We have our emitter, which is creating these particles we already see there from our point cloud. And we have a bunch of other stuff that we sort of need for, you know, when we want to stylize the way the particle, the strands look and things like that. We don't really need these here right now, so I'm just going to hit delete and get rid of them. And yeah, let's just adjust our options here. First off, right now, you see there's, if you're familiar with LKLightning already, there's a bunch of new options here. And it might look a bit scary, but it really gives you all the power you need to do almost whatever you want. So right now, these are set to the dynamic mode moving by time. So right now, if I drag along my slider here, these are moving up. And as you can see, we're not really simulated here. It's just all immediate and dynamic. Fantastic. But that's not what we want. We want them to be up at the same height all the time and then sort of move them around. So we'll just switch this to static. And there we are. They are up there. Fantastic. But this is quite a few too little particles, so we're going to have to increase the emit rate here. And this is set to a single emission, which is what we want, opposed to sort of emission over time. So let's see how many particles we have in here. In our point cloud, 494. Fantastic. So here in our emitter, let's set that to 494. Alternatively, you can go in here, and we have our emit rate exposed here, so you could just maybe get the point cloud and do get data and just use that, the number of points there, to drive the emit rate. Let's just get the set size. Fantastic. And now this will always work. And if I now go in here and let's say adjust the number of particles in my original grid, this the LKLightning simulation will always match. So if I go very dense here, it matches it. So that's good. But I think 50 will be fine. And yeah, so we're pretty much done with our basic setup. Let's go to shaded here. Oh, that's kind of cool. We should have boxes though, so we should switch the particle type on the emitter to box. And if we take a look at this now, bam, there's our box. Maybe I should switch to a better layout here. Ice tree, fantastic. Let's refresh this. Cool. So basic setup is there. Now what we want to do, we want these to sort of move out to the sides as we saw here in the video, and sort of maybe do a swirling motion. So let's have them moving out. The ideal for this is, in my opinion, the proximity controller, which basically looks at the particles next to it and says, hey, do I want to move towards them or do I want to move away from them? So you can basically cause clumping or the opposite of clumping, so them going apart. And if you are here in LKLightning, you can just go through these different tasks. You can go to control, and there's a bunch of controls that give you a lot of options on how to manipulate your strands and particles in whatever way you want. But we just want the proximity controller. and we can just put this in our controller direction here in the core. Everything pulls into the core as always. As you can see here, it's set to attraction, so it's clumping them together, which is kind of fun. It's kind of a fun effect. That looks weird, but we don't want that. We want them to move further away from each other. So let's set this to separation. And this is sort of a start, but it's definitely way too strong, and it also, everything is moving away from everything, and we want it to be a bit more local. So let's dial down the strength first, maybe something like 0.6 or something. Also, I don't think we need so many segments. If you look at the core here, it has a couple of options where you can decide how big the scene is, how big the scene scale is, and how many samples you want along the trajectory. I think something like 10 here will be fine, and the scene scale could also be a bit lower. Yeah, maybe like 13 or 14. Yeah, that looks good. And now let's see here how much we want. I mean, this is definitely too little. So I'd say something like 0.2. Yeah, that's getting there. But it's still everything moving away from everything, and that's not really what we want. So let's enable on our proximity controller here the cutoff distance. And this will say only look at the fellow strands that are sort of in a certain area around you. And we can play with the cutoff distance here to get different effects. And it's still kind of a bit too strong for my taste, so maybe 1.8 or 1.6. And this is looking solid enough. Yeah, maybe something like that, like 10. But this is everywhere right now. We don't really have any way of controlling this. So we have this null moving around here, and that's what we're going to do now. So let's get ourselves a nice null. There it is. Let's make it a whole bunch bigger. And let's switch it to rings, just to, make it sort of visible. I really don't like the original symbol. Anyway, so yeah, we can just pull this null into our LKLightning ice tree and say, hey, we want to modulate this controller with our null. So let's do that. And there's a compound for that. It's under the controllers, and it's LKL modulate strength by null. Really cool. So just drag that in there, connect them up. And we don't have a null connected, so it's broken, but not anymore. Bam, there we go. So right now we don't see anything, but as I move this null closer, ooh, it's breaking up, and it's breaking up really nicely. This looks really organic, quite cool. So let's take a look at our options here in the modulate strength by null. So basically this is sort of, it's falling off at a maximum of 50, so at a distance of 50 units, there won't be any effect. So between here, the null, and sort of around here, there it's 0. There is no effect there. But it's even though we have this fall off here, it ends still quite a bit abrupt. So what I would like to do is sort of have a bit of easing here, and this is what the curve is for. This really allows you to manipulate this however you want. And now I can I can even, move this up and make it stronger when it's a bit closer away, and whatever. You can play with this however you like. But if we do this here and sort of ease this in, then it will be a bit more of a, a bit more gradual effect. And now we can really see it sort of slowly breaking up there. So that's kind of cool. And we can just move this around, and as you can see, I mean, I can just, jump wherever, and I can just move it around. I don't need to simulate anything. It's always just there and available to me at any point. And yeah, I guess we can just sort of animate this. So let's start out with it being completely whole at frame 0. Let's go to our keying panel here, and let's set some keyframes. Maybe 15 frames, move it over there. It's cool. Move it up a bit. Maybe sort of go up there. Oh wait, no, let's move it a bit to the side here so it sort of goes along the trajectory. If we move up here, then it will get that before it gets to that corner, which is not something I want. And now maybe 15 frames further down we can go sort of to over here. And then finally make our way down here towards the end. Like this. And I mean, you can get a lot more creative with this. I'm just showing the technique and sort of move it off here towards the end. Let's take a look at that. And you can see we can jump wherever we want in here. Just go through it. Do I like this? No, I don't. I don't like this. I think this should move a bit more like that. And we should have a keyframe a bit further down here, where we're sort of here. Fantastic. Okay, so now it really sort of starts off at the bottom, travels along, moves up there, stays for a while, and then whoosh. Nice. Okay, so of course, if you do this for a real project, you can take a bit more care with this, but you know, this will do for our cases. And you know, you could take another controller, maybe, oops, not that one. Maybe the turbulence controller. Sort of give it some randomness. So let's plug this in here. And ooh, chaos! So obviously this is way too strong. So let's just dial this down quite a bit, you know, to maybe like 0.6. And let's play with the scale of the turbulence. Make that a bit bigger so that it has that swooshing motion that sort of a wave is going through it. And maybe let's switch the size to 50. And this really gives us some uniform stuff here. That's cool. But obviously we don't want this everywhere, so we're just going to take another one of these modulate strength by nulls and plug it in between this one. Connect it up to the same null again. And now we also have sort of this random motion. And we can see the difference if I enable and disable this. And this is still way too strong. We have quite a bit of intersection there, and that's not what we want. So let's maybe switch this to 0.1. And that gives it a bit of randomness. I mean, you can take this, you can leave this out, you can experiment with a whole bunch of these controllers, and you can really get some very unique results. Anyway, so you know, if I mean, if this was a 4 or you know something that only had straight edges, we'd be fine. But since the 7 has quite a curvature here, and we don't live like in 8-bit land, we're going to have to straighten this out. But unfortunately, we can't really do that with particles, so what we're going to have to do is mesh this. Now, luckily, that's not a problem at all. We just go to primitive and LKL mesh selection, and this will create a mesh out of it. Now, it won't right now. Why is that? Because, as you can see here, let me open the Explorer. Here is our new mesh, and if we refresh this, come on. Give me here. There we go. Here's our measure, and it pulls our simulation in. It is set to strand orientation. That means basically it uses the strand orientation of our simulation, of our LKLightning point cloud. And we don't have that right now. Why is that? Let me go back to that cloud and take a look here at the core. Here we have quite a few options. We have the options of calculating motion blur and also orientation. Now, why isn't this enabled at default? It's because it's sort of an expensive calculation, you know, getting sort of orientation in a non-simulated way right so that it doesn't flicker and doesn't jerk around all the time is a bit expensive to calculate, so it's disabled on default. So let's just switch this on. And oh, not only do we have orientation now, we also have a mesh. So let me just hide our point cloud. And here we have our mesh. Fantastic. Now, right now, this isn't exactly what we want. So let me just refresh our ice tree here and take a look what we can do about that. First off, we need boxes. These need to be squares. So let's switch our strand radial resolution from 3, where it is right now, to 4. And this is already looking quite a bit better, but we have a lot of space in between there, so that's not what we want. Let's just go to a top view and adjust that, and we can just do that simply with our size. Let's see if we can find the right value here. Maybe something like 4 or 5 around there. Good guess, not quite. Man, that was quite close. 0.4. Yeah, I guess we can get it a bit closer. 0.445. Sometimes we just have to dial in some numbers. Damn it, that was too far. Okay, I'm going to go with 1.442, and I'm going to call it good. If we take a look at this now, let's see. Does this? And in the preview, it looks like it has some seams, but it should shade plainly. Let's adjust it here. Yeah, and you see this shades as if it was one surface. So that's cool. That's pretty good. And yeah, we can just jump wherever in here. Go like here, and there's our mesh. We have our LKLightning point cloud meshed. Fantastic. And you see, it really behaves absolutely smoothly. There's no jerking around here. And yeah, it's working really quite nice. So nothing much accomplished. We have our mesh, but now we actually need to turn this meshed simulation into something that has these curved edges. So let's take care of that. What we're going to do here is we're going to take one of these meshes where it's sort of meshed, and we're going to freeze that, and then use a boolean to cut off these the surplus of edges here on the side. And that should give us, basically a good mesh that we can then skin back using LK Skinner onto our simulated mesh. Sounds a bit convoluted. Don't worry about it. You'll see it will all work out. So let's go back to the beginning of the timeline and hit Control D to duplicate it, since we'll need the simulation, but we'll also need a frozen mesh. So actually, I think if we cut this out here, we might run into some problems with sort of here on the edges where there might be some left free space in here. So what I'm going to do is I'm going to take my 7 mesh over here and use a push on it just to make it a bit bigger, so that we have a few more strands on either side, so that we have a bit of room to play with. Okay, so let's duplicate this, and this will just be our original, and then I'll call this one pushed, even though it's not pushed yet, but we're gonna get there. Fake it till you make it. Oh god, I'm so funny. Oh, jeez. Anyway, so this is frozen. This is fine, and yeah, we can just go to push. And since we set everything up so modular earlier, we can really just pull on this, and it will just create more points for us, and everything will work. So let's just push this until we have a couple more points on either side, on every side, and this looks good. Yeah, I like this. Fantastic. Okay, but yeah, that should be enough. Okay, let's freeze this. This is our pushed version, and if we take a look at our original, maybe from the top, let's see if there's anything left visible of it. No, this should be fine. It's always in there, and we can just use that to cut out parts of our generated mesh. So that's cool. Let's go back to user view, and as you can see, our mesh, it's all modular, it adapted, we now have more pieces here. Fantastic. And this is kind of looking cool. This is the way it formed an edge up here. I like. This kind of looks like something, a 7 like you would put on a sports on a uniform. Anyway, so let's duplicate this one, and let's call this let's just call this meshed _ static, since that will be the one we'll be cutting into with the boolean. So let's freeze that, and now we need something to cut the sort of the curvature of the 7 out of this. So let's go back to our original. I kind of want to stay with an original version, so I'm just going to duplicate this again and call this like the boolean version. Boolina, well, who cares? And yeah, so we need to move this up a bit, maybe scale it up a bit, and that looks good. Yeah, it's completely inside there. Yeah, this should give a decent Boolean result. Now, pray with me, as everyone who's ever used Softimage knows, Booleans don't always behave the way you want them to, so let's hope this works and I don't have to do a bunch of cleanup. Okay, so this is our static mesh here, and this is our boolina. No, I'm going to stick with it. I made the mistake. I'm going to stick with it. And yeah, let's go to polygon mesh, Boolean difference, select our boolean and wait for it to cope. And it did, but I chose the wrong one. I don't want the difference, I want the intersection. So let me Control Z that. Let's go to Boolean and intersection. Please, dear lords of the Boolean, yes, you are gracious, thank you. Wonderful. So there we go, we have our straight 7. That's really fantastic. So yeah, you know, now we can just freeze our Boolean baby here. And we'll just leave this for reference as static. I always really like to leave backups before I put any simulations and stuff like that on anything. So I'm just going to make a duplicate of this. And this will be our meshed curvature, is that how you, yeah, whatever. Curvature and skinned. So this will be the one mesh, our final mesh, which will actually skin to the simulation or the new meshed version of our LKLightning original simulation. Jesus. Okay, so many meshes. Anyway, so let's go on this one here and let's refresh our ice tree. God, Explorer, get out of the way. And there's nothing on here. So what we'll do is we'll create a simulated ice tree. And then we'll search for the dear beloved compound LK Skinner. And you can find that in the LKLightning under utility. That's pretty good one. And what this does basically is it, at the beginning of the simulation, it takes a look at the timeline, it takes a look at where are the points in the mesh and where are the points of that of another mesh that are close to it, and then it mimics the motion the mesh it is looking at is making and moves that with it. And this is a very useful tool for skinning, for example, high-res geometry to sort of a low-res simulation, or to, for example, skin this here, this curvature and Boolean 7 to its simulated version. So let's take this. Going to need our simulation. Where's our mesh? Here. This is the one. If we go through this here, this is the one that has the movement on it. So we need to skin into this. It needs to follow the movement of this one here. So let's just go back. Let's hit F3. Pull this mesh in here, and we're just putting this in here in deformer meshes and plugging it in. And you know, we can actually just hide the version with the simulation on it. It will evaluate anyway. And here, so this is our straight one, and you know, we can just go anywhere in the simulation, maybe around here, around 13, and we'll chew through. It will follow the motion of the simulated one, or rather, it will follow the motion of the mesh that is meshed from our original LKLightning point cloud over here. So we have a lot of things interacting with each other in a very cool way, but you know, as you can see, it works. And now here we have our straight cut piece following the exact same motion as our original strands, and this is pretty cool. So I guess, yeah, all I'm going to do now is just cache this, and then we can look at this, you know, in real time. So let's just go back to the beginning, and let's go to ICE, Simulation Cache Manager. Let's write a cache, add this object to the selection, and what do we want to write? We really only want to write point position. 100 is fine, and yeah, let's just write this. And I'm going to pause the recording real quick while this chews through for a minute. Okay, so it has finished, and now we've written this out. By the way, if don't just use the LK Skinner for this. It really is a very diverse compound. It can do a lot of things. It's really cool. So it can help out in a lot of production scenarios. Try to find uses for this outside of LKLightning. So we have this, everything is fun, we have our cache written out, so let's just hide our skinned version, take our static version, make another duplicate of it, and let's name this cached. And this will just apply the cache to this, and this will sort of override these point positions with the point positions from our cache. So let's go to read, let's add the object, and let's find this thing. Okay, and let's hit apply. And yeah, now we should be able to just jump around in this however we want. Bam, fantastic. So yeah, let's full screen this. That's LKLightning 2.0. It can do a lot of cool things like this, for example. As you can see, there were a lot of compounds along the way we didn't use. So, just play around with it. This will be out soon enough, and you'll be able to find this under leonardkoch.com. I'll provide a link wherever you'll see this, maybe on YouTube or in a forum or something. And yeah, I hope you really experiment with this. As you can see, it's a very intuitive workflow. You can really just play around with this stuff however we want. And it's very interactive. You don't have to wait for simulation times a lot. And it was really just only this final step where we cached it, where we had to wait for a while, which is just so different from our usual approaches for jobs where when you have a dynamics job like this, you just spend sort of maybe 5 to 10 seconds thinking and modifying some parameters in the ice tree, and then you'll wait for like 5 minutes for the thing to simulate and for it to cache out again so you can look at it in real time. That's just not the case with LKLightning. Works out a lot faster, and you can iterate faster and get some really cool results. And whenever you have that much freedom like this here, you make better stuff, When you can play with something, it comes more intuitive, it, engages different parts of your brain, and it really makes for better results. And I hope you have some really fun stuff with this. And yeah, just, mess around with this. I hope this was helpful to you, and I'll see you with another tutorial maybe soon. And yeah, have a good day. Bye.